right, so I'm outside on this cold winter morning, and I have a graph, as you can see, and let's go ahead and hit start so I can get to the explanation. So you can see here, I have a parabola being graphed, and if you notice, there's two different colors. Normally, if you ask students, okay, why do you think one side is red and one side is green? Most of them will be able to come to the correct conclusion. They're like, okay, this is red because this is decreasing. See what I'm saying? You know, that's decreasing right there, red. Oh, it turned green when it started going back up. So it turned green when it was increasing. So this is our original graph. So we start with the original graph, and then in calculus, this is a good time to start talking about, okay, what do derivatives mean? All right, so here we go. And as you can see, not only do I have my original graph here, I also have my derivative graph. So let's move forward and let's take a look at this. Notice right here, the derivative is negative. And then right here, the derivative is positive, right? And I don't know if you see this one dot. This one dot in particular is special because this is the exact moment our derivative hit zero. So you got negative, you got zero, and you got positive, just like a number line, right? So what does that mean? All right, if we think about it in terms of what's going on the graph from this angle, see, the derivative is below the x-axis, which means our derivative is negative. You see where it turns blue, right? For a brief moment, that's when our derivative is zero, and then everything above the x-axis is now green. That is how we connect what we know about a derivative graph to what's going on with the original function. All right. So I just kind of wanted to talk about that. I have two separate graphs going at the same time. This is a good way to connect what a derivative graph means when you relate that to its original graph. All right, so let's look at something real quick. First of all, I want us to look at the original graph, which is the parabola. Notice when the parabola curves in a downward direction, when it goes downward, that's decreasing, which is red. Then it increases on green, right? So this is one of the things that we have to first wrap our minds around in calculus is this point right here at the bottom. That's what we call a minimum value. Now, if it were upside down and it went in the other direction, we would call that a maximum value. Whether it's minimum or maximum, the one word to describe either one of those two are what we call extreme values, all right? So extreme values is the word that describes either a minimum or a maximum value. So I want to go ahead and show that. And so as you can see, this part right there is an extreme value, which happens to be a minimum. So a minimum happens when a function goes from decreasing to increasing. If I go from red to green, that has to be a minimum value. All right. And look what happens here. I went from red to green. That's a minimum value. So it's easy to locate a minimum value when we talk about the original graph itself, because you can look at it and say, okay, there's the minimum value, right? But if we are trying to figure out minimum values based on the derivative, then we got to think about what this means and what I said earlier. And what I said earlier, remember, if I go from decreasing to increasing, anytime you go from decreasing to increasing, that point right there in the middle, that means we had to encounter some type of an extreme value, and specifically the extreme value that we encounter was a minimum. And when we bag out, that's exactly what we're looking at. So that's why we have to understand these concepts and how to interpret both graphs, because they both can give us information that is useful.